Hello Niners! In this video lesson we will answer a problem involving the angle between two lines. In this case, we will find all the interior angles of the triangle ABC given the coordinates. In short, we need to get this angle. So let's call this theta 1 or angle 1, this theta 2, and this theta 3. Now, the formula that I use to get the angle between the two lines is this formula. Tan inverse of m2 minus m1 over 1 plus m1 m2. Very important in the formula is the numerator. Which slope should be subtracted from which? So, the slope should be of the initial side. And this should be the slope of the terminal side. Remember that we always measure our angle in standard position, counterclockwise. So we'll have that later. Now, since in the formula to get the angle, what are involved are slopes. Let's get the slopes of the sides. So let's get the slope of this. 5 minus 2, 3. 4 minus negative 5, 9. That's 1/3. Negative 1 minus 2 is negative 3. 3 minus negative 5 is 8. So this is negative 3 or 8. 5 minus negative 1 is 6. 4 minus 3 is 1. So the slope of this side is 6. Now we have all we need. Let's do it one by one. Starting with the angle 1, of course. Theta 1. Okay, now this is 1/3. This is negative 3 over 8. And of course, this is the angle. Remember that to trace the angle, we measure, we always move in the counterclockwise direction. So we have to start here, this side going to that side, counterclockwise. So this slope, negative 3 over 8, should be your M1. So this is equal to tan inverse. The M2 would be 1/3. Then minus negative 3/8. That becomes positive all over. Simply the product 1 plus the product of the two slopes. 1/3 times negative 3 over 8. Now this is, when simplified, will be tan inverse of, wait, you have your calculators, you can get it now, and so we can finish this fast. So we'll get here, simplified would be 17 over 21, and getting the tan inverse of 17 over 21, again, calculators, you have, get one now and help me get the exact measure in degrees. So rounding off to decimal places, our theta 1 is 38.99 degrees. Okay, so we have here theta 1 38.99 degrees. Now let's go to the next. Let's get theta 2. So theta 2 is this angle. So this is our theta 2. The lines involved have slopes. 1/3. This is 1/3. This 6. Then again, using the formula, tan inverse. Should be no problem in the denominator because all you need to do is multiply the two. M1, M2, 1/3 times 6 will give you 2. Then you should be very careful. So numerator. In the numerator, which slope should be subtracted from which? Again, how do we draw the angle from in standard position? Counterclockwise, so we have to start here, counterclockwise. So our slope that we put here should be 1/3, and this is 6. So simplifying this is equal to tan inverse 6 minus 1/3 is 4. 18 over 3 minus 1/3, that's 17 over 3, all over 3. This will be 17 over 9. So again, calculators to get the exact measure in degrees, and let's just round it off into 2 decimal places. Tan inverse of 17 over 9 will be 62.10. So our theta 2. So our theta 2 is 62.10. Then lastly, get theta 3. Let's put it in the first page. 62.10 degrees. Now, see, we have already found the measures of theta 1 and theta 2, and we know the angles, the sum of the angles in the triangle theta 1, theta 2, and theta 3. The sum of all the angles should equal 180. So we can easily get theta 3 by adding this 2 and subtracting it from 180. But for the sake of this more exercise for getting the angle between the two lines, let's get theta 3 using the formula, and then let's just check if it all fits. So theta 3, so this is our angle. The slopes involved here are 6 and -3 over 8. Again, I said there really should be no problem in the denominator, because all you need to do is multiply them. So it will be -3 over 8 and 6 multiplying the 2 and adding it to 1. The numerator, we should be very careful again, which slope should be subtracted from which. Again, in standard position, measuring this angle in counterclockwise, we have to start counterclockwise. We have to start in this side going to the other side. So this should be 6 and this -3 over 8. And if we do that, simplifying this, I already simplified this using my calculator. So you get 51 over 10. And theta 3 is tan inverse 51 over 10. Let's get the exact measure in degrees. That would be 78.91. So theta 3 is 78.91. Now we can now check if what we had, all the three angles that we had, are correct. If we add them up, 38.99, 62.10, and 78.91 should all add up to 180 degrees. 180 degrees. Okay, so again, on to my favorite part. I have here a triangle given the vertices. You see, you can get the coordinates of the vertices. It's plotted. I want you to find the interior angles of this triangle for practice. So easy way to check is when you add all your angles, this, and this, it should be 180. Good day, juniors.